Hello everyone, this is Neil from Edureka and welcome to today's session on our tutorial. So let's not waste any time and let's move forward and look at today's agenda. We'll begin this session by first understanding why do we need analytics and what exactly is business analytics and why do we prefer R over the other tools in the industry. After that, we will begin by deep diving into R by understanding the basic fundamental concepts like variables in R, data operators, data types, and flow control. Finally, towards the later half of the session, we'll try to understand how you can plot the various types of graphs in R. So are we clear with today's agenda? Okay, so I've got a confirmation from Eric, Shubham, Dave, Roshni, Gayatri, Reshma, Pankaj. Okay, it's great to see that all of you guys are following. So I hope you guys are excited for the session as I am. So let's not waste any more time and let's move forward and look at the first topic for today's session, that is, why do we need analytics? Now, before we actually move into the content in the slides, I just want you to spend 2 minutes to have a thought and let me know why do you feel we need analytics? So the most common answer that I have got from you guys is that we use analytics to make better decisions. That's perfectly right, but analytics is not just used for making better decisions. There are many major things that analytics helps us achieve. So we'll mainly be discussing the need for analytics across 4 major points. Now, talking about the need for analytics in an organization, we can come across these 4 points. Now, the first point is cost reduction. Now, every company invests a huge amount with respect to different resources that they take in. It could be an investment on another company, it could be investment on the same company across their employees, it could be with respect to certain marketing campaigns that they're running, certain research they're putting into. But how do they know which is going to be successful and which needs more investment and where you need to cut short on? And that's exactly what analytics helps us achieve. Through analytics, we can identify which section is actually performing well. Now again, let's say you're investing maybe 50 million on 3 companies as such. So not all companies achieve the same level of performance and give you the same reward with respect to that. So you would definitely prefer to invest more in a company that is giving you more rewards. And to know that, what you need to do is you need to analyze the performance of that company. Now this is a big example. Let's take a smaller example. We end up spending money on a lot of unnecessary things over the month, and at times we end up short over the month end. Now I personally have experienced this a lot of times, and here what we actually need is to analyze and reduce the cost expense that we take up on a regular basis. I personally had invested a lot of my money into fitness side. So finally, after some time, when I had checked how was I making the right decision investing there, I realized I wasn't. So again, those are one of the key things that help you identify and make a better decisions with respect to that sale. No, Eric, I didn't stop going to the gym. I just increased that and reduced a certain level of unnecessary investments. So again, those were decisions I had made after carefully analyzing my investments as well as my opportunities, which in turn also helped me reduce the cost that I was spending. So the next key point that I would be talking about is better marketing. Okay, now again, it's always important to understand how the present market is and what is the public demand as well. Once you understand that, it becomes easier for you to market your product according to the requirements of the user, as well as create a better product that would meet the requirements of the user in itself. Now, if you have a good product by yourself, then almost everyone would definitely go for your product rather than any other product in that market. So this can be achieved through analysis. Similarly comes making better decisions with respect to your investments and marketing. Now, if I know how the market is, how the trend is, how things are working in the market, then it's easy for me to make a decision that could have normally taken a lot of time. This is basically because I've already analyzed the market, I've already understood everything, I've understood the requirements, the needs, and even tried out a few models where what would happen if I had done this. I would have even tried out some scenarios with respect to that same. And once I've tried it, I've experimented all this, I've analyzed the complete result, then it's piece of cake for me to make a decision call there. So it's quite fast when you compare to a rather risk-taking situation where I do have no idea how the market is, I've not even bothered thinking of what is the requirements, but still I'm just going with that flow. So data analytics definitely makes it easier for you to make better business decisions and better marketing policies. Finally comes organizational analysis. Now every company needs to understand where they are in the current race. Now to do that, one of the key factors is to help understand how they are performing themselves. Now organizational analysis helps them understand how they are performing as an individual as well as an organization as a whole. Now, we've all had our shares of reviews. There are quarterly reviews, there are yearly reviews. All that comes into picture and helps the organization understand better who's actually devoting more towards the organization and whom to take up the chain with respect to that. Now, we've definitely seen this on our day-to-day basis because we've seen certain people who do perform extremely well being pulled up when compared to people who've got more experience as such. So always this analysis that is done within the organization helps you achieve better result as an organization as a whole. Now with these 4 points, I hope you guys have got a simple understanding as to why we need analytics in an organization as well as on our personal life aspect as well. Okay, so I've got a confirmation from Shubham, Reshma, Eric, Pankaj. That's great to see, guys. So again, please make sure at any point if you're not clear with any concepts or if you have any doubts or even if there's something that you want me to repeat once again, you put it across in the chat box. If I have to repeat a same concept 10 times, I have no problem, but I want to make sure that you guys are completely clear with respect to what we're discussing as part of today's session. Okay? Keeping that in mind, let's move forward and try to understand what exactly is business analytics. We've understood why we need it, but then comes the question on what exactly is business analytics. Now, business analytics basically is the process of examining the large set of data that you have and achieving a hidden pattern or correlation between that or even a better insight as to what you need to do. It basically helps you understand with all the data that you have gathered. This could be your organizational data, it could be the market research, it could be your product research. Once you've completely analyzed all these data, then you could find something that you are lacking on. Once you've identified this, then it becomes quite easy for you to make better decisions, better products, better marketing strategies, and so forth. Now, again, if you look at the image here below, this is exactly how your data is at the moment. It's a scattered mess. Okay, you've got everything that you want present in your data, but to find anything specific becomes a problematic. And to understand how you're doing is an even bigger mess. So to achieve all that, you need to use analysis. Through the analysis process, it becomes easy for you to make a correlation and a structure across the data that you have so that it becomes easy for you to go ahead and make the better decision. Now, analytics is not the complete solution as such, and it helps you understand how you're exactly doing at the moment with respect to what you have already tried out as well. So once you have established the path for you to move ahead, it becomes quite easy for you to make a decision on which path you want to go follow and which path will take you for the betterment of your organization. So clearly here? Okay. Now the result of this analysis that you've performed may not be something that could be always understood by someone who's not from an analytical background. And this at times becomes a hindrance because you can't expect the people in the chain above to always understand the raw data that you're providing them after analytics. So to overcome this gap, we have a concept of data visualization. But what exactly is data visualization? Data visualization basically is a visual access to the huge amount of data that you have generated after analytics. Now, again, when you talk about why we need to use data analytics, it's a quite straightforward and a simple understanding that the human mind processes visual images and visual graphics more better than compared to raw data as such. It's always easy for us to understand a pie chart or a bar graph better when compared to the raw numbers that you would be providing me. And this is something that's common for anyone across because this is how our human minds have been set. Now, you may be wondering how can you achieve data visualization from the data that you have already analyzed. Now to do that, there are major tools in the market at present. These are some of the major players in the market at present. Now here you have Tableau, ClickView, R as well as Pentaho BI, and you can see a lot of other tools as well. Now, these are some of the major tools. Now, again, when you look at Tableau and ClickView, those are tools that are completely dedicated to data visualization itself. Okay, but then again, you all must be wondering, when there are already these tools that help you achieve data visualization and certain amount of analytics, why go with R? And that's exactly what I'll be explaining. Now, when we talk about why R with respect to other tools in the market, one of the two major points that I would definitely like to bring out first itself is R is both a programming language and a statistical language as such. Now, I'm quite sure that some of you would have at least heard that R is hard and is not one of the easiest subjects that you can pick up. But trust me, with respect to R's capability as a programming language and a statistical language, it is the best in the market. Okay, and when you look at how easy it is to code in R, then you'll definitely realize how things are. Apart from that, R can be used for both data analysis as well as visualization. Now, if you look at some of the other tools that we had seen in the previous slide, they are tools that are specific to achieving either data analytics or data visualization specific. But with R, you can achieve both analysis as well as data visualization in a single tool itself. So here again, it becomes a tool for multi-purpose. Now, apart from this, R is one of the simplest languages to learn, as I had mentioned earlier. Now, R is quite close to the English language. Therefore, writing codes in R is a piece of cake. Okay. Now, in today's session, we will be trying out a lot of codes as we're going into R. So at the end of the session, you will completely be able to understand how easy it is to learn and how simple R is for performing various operations. Now, one of the key reasons as to why R is so popular is because it's a free and an open source project. Now, again, when you talk about free and open source project, it basically means that anyone can download it, anyone can modify the original source code of it, and anyone can feel free to redistribute this code as well. So R lets you completely play around with its source code itself. So if someone is actually doing that with their product source codes, then you can completely understand how popular, how open, and how big the community is with respect to that too. Now R has a very huge community comprising of both programmers and analysts. So here you can find both flavors and everyone is quite friendly and helpful. So at any point, if you have certain queries along the line in your career using R, feel free to reach the R community and you can definitely find someone who will be able to assist you. So any questions still here about what is data analytics, what is data visualization, and why R exactly? Okay, Pankaj is asking me how is R better than Tableau? So Pankaj, again here when you see, definitely I would say Tableau helps you achieve better visual graphics. But for Tableau you need to always feed in an analyzed data set. Okay, so there once you have your analyzed data set, then you can perform certain operations like filtering out or selecting certain amount of data. But through R you can actually completely perform the process of analysis, and there itself you can achieve your data visualization. You don't need to depend on any other tool for achieving data visualization with respect to the data that you have achieved through analysis. So basically you're reducing the need for another tool itself. Is that clear, Pankaj? Okay. So with this, it's time we begin deep diving into R. And the first thing that you guys need to do is install R on your system. Okay, to do that, all you need to do is go to the official site of R, that is cran.r-product.org. Let me just show you that. So you can just open your browser and search for download R and you get the first link. Now the first link is for Windows. For those who are working with Windows can directly click on this and go to click on download option. Okay, for those of you who are working with different operating systems like Mac or Linux, you just need to go to their home page and here you have the option for Mac and Linux. Again, inside Windows, you need to always ensure that you're downloading the base option because that's exactly what you need as part of this session. So once you've gone ahead and downloaded this, an exe file would be downloaded. So again, if you click on, basically redirects you to the first page that we had come in. So just click on download for Windows and you can see the exe file for downloading. So just save it. Now I've already installed it on my system. So you guys can download it and go ahead with the installation step. It's quite easy. All you need to do is just keep clicking on next. So please go ahead and install, and if any of you are facing any troubles, please let me know so that I'll be able to assist you. Okay, so it seems like all of you successfully installed R on your system. Now, you can directly begin by coding in R, but what I would recommend is you go ahead and install the R Studio IDE. Now, the purpose of an IDE is basically to make it easier for you to program, and as beginners, I definitely recommend that you begin with downloading and installing the RStudio IDE itself. So again, with respect to the purpose of downloading and installing an IDE is basically to have a common environment for working with respect to your data, and as well as becomes easy for you to learn about the various possibilities and understand about your mistakes in an IDE better. So you can go ahead to RStudio's website. Let me just show you. So you need to search for RStudio download. So let me just show you the home page for RStudio. So this is the home page for RStudio, and you just need to click on download RStudio option. So here you can see different versions of R that are available. So I would recommend that you download the R desktop version here. Now, apart from having a free version, they do have a paid version, but again, I would recommend that you go ahead and download the R desktop free version from this page. So if you click on download, you can see the various options with respect to each operating system. So again, choose the version that suits your operating system. Just download it, and then again the installation is quite straightforward. You just need to keep clicking on next. So if any of you are facing any troubles, let me know, and then I'll be able to assist you with respect to that same. Okay, so now that all of you installed RStudio on your system, so this is basically how your RStudio looks like. So to your left you have your console, to your right you have your environment window, and finally you have one of the most important windows, that is your workspace window. Now here basically you have multiple tabs here. Now again, files that you want to work around with, you have your plot. So basically any graph that you're plotting can be seen here, and then you have your packages tab. So these are very important options. So let's say you want to install a specific package for your R program. All you need to do is click on the install button here, and then you can select whichever package that you want. Let's say I want to install a package called ggplot2. So again, I just have to type ggplot2, select it from here, and then just click on install. So basically what happens is R actually checks with its libraries, and then it goes ahead, downloads the package and installs it as part of my RStudio. So once downloaded, you can find it here. So any package you want to understand what exactly it does or how it works around, all you need to do is just click on the package name, and then here you can find the complete help page for that package. So here, let's say if you go to ggplot, then you can find the description, the usage, the argument it takes, the details, and so forth. Okay, so this is a package basically used for graphical representation. So I hope you guys have got a simple understanding on working with the RStudio. Okay, so now let's go back to our presentation and begin by deep diving into R. Now the first topic that we'll be discussing as part of the fundamental concepts of R is a variable. Now a variable basically is nothing more than a reserved memory location used to store certain values. Which again in turn means, let's say if you're working with a value, then that value needs to be stored in that memory. And to store it in a memory, you're going to be creating a variable. So it's a very straightforward, simple definition. Now there are three ways you can actually create a variable in R. Okay, if you look at the image here. Now again, I can directly write the variable name equal to the value, or the variable name, a less than symbol followed by a hyphen and equal to the value, or even the value hyphen a greater than symbol and the name of that variable. So these are again the three ways you can declare a variable in R, but again in turn all of them have the same meaning in the memory location as such. Okay, so again let me just show you how you can declare a variable in R and how it actually works out in the RStudio. So let's go back to our RStudio. I'm going to say my A equal to 25. Okay, immediately when I type this, I want you to observe the environment window. When I give enter, automatically a new entry has been pushed into the environment variable saying that the variable A of numeric type, okay, which is occupying 48 bytes, has the value of 25. So this is something automatically done. Same way, let me say B, and I'll just give a string value. So let's say, hi, how are you today? Okay, so this is a complete statement. When I give enter, you can see here the value has a new variable has been created called B. The value also has been set, and you can see the memory location allocated to it. It's a character type and it's occupying 120 bytes. So apart from this, you can also work with Boolean value, let's say true or let's say false. So I'll give it to value C, variable C, and enter. So here you can see I've declared three variables, but again the way I have declared them is slightly different, but the end result for all three of them is the same. So again a new variable is being created and the value has been assigned. So here if you look at C, basically it's a logical type and 48 bytes have been allocated for it. Okay, so please go ahead and try these things again. I know it's a very small thing, but again it's quite important to understand what is a variable and how to work around with variables when you're working in R. Okay, now one key thing with respect to R while you're in comparison to other programming languages is that you don't need to actually define a data type for atomic data types. Again, what exactly is an atomic data type we'll be seeing later, but to give you a simple understanding, your integer, your numerical value, your logical value, your strings, so all these don't need to have a data type defined while you're creating them. Again, it's a quite easy and straightforward language. Now, this is something that you would have seen while you were working with Python if any of you actually tried it out as well. So clearly here with respect to what is a variable and how to declare a variable in R. Okay, that's great to see all of you have understood it. So now let's try to understand the various data operators that are present in R. So there are mainly 5 types of data operators that you'll be working around with R. You have your arithmetic operators, you have your assignment operators, relational operators, logical operator and special operator. Okay, so we'll start off by first understanding arithmetic operator. Now arithmetic operators are quite straightforward. You have your addition, subtraction, multiplication. Now if you look at the examples to the right here, again 2 plus 3 is giving me the answer, but plus 2 can also be a sign that it's a positive 2 value. Again same with subtraction, 3 minus 1 is giving me a result of 2 and minus is actually used to denote that it's a negative 2 number. Multiplication and division are quite straightforward. Let me show you how they work out in RStudio. So here let's say I already have a variable a. So what I'll do is I'll create a new variable d equal to 5. Okay, so let's say a plus d. You see the output as 30. A minus d. Again at any point if you want to see the value of a variable, you can just type the variable name and the output is correspondingly shown there. Okay, so apart from seeing the value here, you can always check it on your console as well. Now let's say a into d is 125, a divided by d is giving me the answer as 5 and so forth. Basically all your arithmetic operations can directly be performed here and then you can go ahead and execute it. Now apart from these 4 basic arithmetic operations, you also have specific operators where you have your exponent operator and then you have a specific division operator. Now again when you talk about exponent operator, let's say d to the power of 3. Okay, so basically what I'm trying to tell is 5 to the power of 3. That is 125. Let's say d to the power of 8. Okay, so this is the corresponding answer with respect to that same. Now again the second operator in this list is basically a modular division. What it basically does is it divides the number, but instead of giving you the quotient, it actually gives you the remainder of the division. Okay, let's say I'm going to divide 22 space percent 7. Okay, now we all know this is going to give us the value of pi, but what happens if I do a modular division here? Then it is actually giving a remainder of 1 instead of the value of pi. Okay, instead of giving me the quotient, it is actually giving me the remainder and it's making the division as terminating. So the last division here is a floor division. What floor division basically does is it divides the two numbers, but the quotient that you get, that is always rounded off to the previous value. Okay, so I'll just clear my screen in the RStudio and let me just show you. So let's take the most useful case. Now again, let's say 22 when I modulo divide by 7. Okay, now we had seen the value to be 1. Okay, same time, but when I say a normal division of 22 by 7 is giving me the value of pi, that is 3.142857. Okay, again this is a non-terminating, but it has chosen to put only 6 decimal points after the value. If I say 22 floor division, okay, of 7, then it is giving me a value of 3. That is, it has rounded off this value to the value of 3. So are you guys clear with respect to these arithmetic operators? Okay, so Reshma is asking me a question. What if the decimal point value is greater than 5? Okay, that's a very good question, Reshma. So I'll show you an example here. Let's take a random number here. Let's say I'm going to take 3.8. Okay, 3.8 floor divided by 2. What's going to be the answer? Can anyone tell me? Okay, I have multiple answers here, both 1 and 2. So let's just check this out. The answer is 1, because as long as it does not reach a complete whole number, it will always be rounded off to the previous number. That is exactly what your floor division does. So does this clear your doubt, Reshma? Okay, that's great to see. Now the next operator is your assignment operator. Now we've seen the assignment operator. You can always use an equal to sign. You can use the less than followed by hyphen. Now again, it can be a double less than as well. So I think we have not seen that. So let me say E equal to 50. Again, same result, a new value has been entered into my environment. So you can see E is of a type numeric, which is taking again 48 bytes, and the value is 50 here. Okay. Now again, same process can be followed for assignment to the right hand as well. Again, let's say 100 hyphen greater than to the variable f. So again, f has been added to my variable list with the value of 100. Okay, so these are how you work around with assignment operators. The next set of operators are relational operators. So relational operators are some of the most interesting operators I like working around in R, because these actually act as a base to various different operators that we'll be seeing ahead. Various statements, various operators are dependent on these simple relational operators, and they're quite useful as well. Now again, all your relational operations will give you a Boolean value as your output. Okay, so let me just show you an example here. Let's say my f is greater than e. Okay, it's a simple statement here. You can see the values. If I say it is true, but let's say e is greater than f, then basically it's returning me false. Same case you can see, and when you want to compare two operators, then you're going to use a double equal to operator. So say e equal to f, then it says false. No, they have different values. And when you want to check whether two values are not equal to, then again it's quite straightforward. Let's say d not equal to. So again, not is denoted by an exclamation mark, not equal to e. Then it says true, both d and e have different values. Again, if you check in my environment list, d has a value of 5 where e has a value of 50. Now, apart from a single operation of less than or greater than or equal to or not equal to, you can combine the equal to with both less than and greater than, where it becomes to greater than or equal to and less than or equal to. Now, let's say d is greater than or equal to e. It's false. But let's say I'm going to take another variable, say g equal to 5. Okay, and then I'm going to say d is greater than or equal to g. Here it is giving me true because both conditions are being checked, whether d is either greater than g or is it equal to g. Only when you've tested these two conditions, whether it is greater than, no, it's false, and whether it is equal to, no, it's false. Only in that case will you get an answer to be false. But if either of the conditions are found to be true, then the answer comes back as true. So are you guys clear with respect to the first three kinds of operators? That is arithmetic, assignment, and relational. Okay, so moving forward, let's talk about the next type of operators, that are logical operators. So with respect to logical operators, there are mainly three types of operators. You have your AND operator here, then you have your OR operator and NOT operator. So with respect to your AND operator, let me just show you how it works out. Okay, so here what happens is, I'm going to assign two new variables. Let's say x is equal to true and my y equal to false. Okay, so let's say x and y. So let's say x and y. Okay, so the value of one is true, the other is false, but it is giving me an output to be false. But at the same time, let's say x and x is giving me a value of true. So your AND operator gives you true only and only if the value of both your operands, that is your left operand here and your right operand here, their value is true. Unless and until both these values are true, you do not get the output to be true. Now again, let's say y and x. So this is false and true. Okay, is giving me false, and let's say y and y is giving me false. So here you can see the only case where I'm getting true is when both my left operand and my right operand is having a value of true. Now keep this in mind. This is something that is going to be very important while we're working with conditional statements. So make sure you're quite clear with respect to how a AND logical AND works. Okay, but similarly, when you look at the next operator, that is OR operator, this is quite interesting. Now again, your OR operator, let's take X again here, and your OR is again denoted by a pi symbol, like your AND was denoted by an ampersand. Let's say X and Y. Okay, this was the first condition that we had checked. Okay, now here what we're checking is X or Y. When I pass it, it gives me the value of true. Your OR operator is opposite your AND operator. What it basically does is, if any one of the two operands is having the value of true, then it returns your output to be true. Earlier what we had seen with respect to the AND operator was only if both the values are true do you get an output to be true. But with respect to an OR operator, as long as at least one of them is true, then the value is said to be true. Now again, let's say you've seen X or Y, let's say Y or X. Okay, this is false and true is giving me true. Let's say Y or Y, then it is giving me false. So again, since I have both my operands to be false, it's giving me the value to be false. Now the final logical operator is the NOT operator. Basically it converts the present value to the opposite value. Now as you know, my Y has a value of false. Now what I'll do is, to that Y I'll add a NOT. Okay, NOT Y, and I pass it, it gives me the value of true. But again, when you check the value of Y, it is false. So your NOT negates the current value. That is, if it is true, it becomes false, and if it is false, it becomes true. So are you guys clear with respect to the logical operators? It's quite important that you understand them well. So all of you seem to be clear on this. So let's move forward to the final operator, that are special operators in R. Okay. Now the first is the range operator. So your range helps you identify, that is, store a sequence of numbers within a specific range. Now you need to specify the first number and the last number between on the left hand and the right hand of the colon. This tells that all the values present in this range have to be stored in a variable. Now again, let's say I'm going to create a new variable, say H, that is going to store a range from 1 to 10. So 1 colon 10. And if you look at H value here, okay, it's having an integer value which is storing the values from 1 to 10. Again, if you want to check the value, you can also print it on your console. Just type the variable name and you can see the values here. Okay, the next special operator basically is an in operator. It checks if a specific element is present in that value. So this is something that you'll definitely be using in a range of values. Now let's say I want to check if a variable, let's say 6, is present, okay, in my H variable. So what it does is, you're checking if a value 6 is present inside your variable, and it is giving me a boolean value whether it's true or not. Now let's say I'm going to check a value 15 in H. Now we know that H is a variable that is storing the numbers from 1 to 10, so this should give me a value of false. So are you guys clear? So we've come to the end of the various operators in R. So any doubts with respect to this? Any of the operators that you're not clear, that you want me to repeat? Okay, so I see everyone is clear. That's great to see. I mean, as an instructor, I'm quite happy that all of you are following. So again, remember, at any point you're not clear with anything, make sure you put it across in the chat box. So let's move forward to talk about the various data types that are present in R. Now, talking about the various data types in R, there are mainly 6 data types present in R. You have vectors, you have lists, you have matrices, arrays, factors, and data frames. Now, vector in itself have 6 atomic data types, but not going into that right now. One thing you may have noticed is that at any point when you need a variable, you can go ahead and declare it as part of your code. So this becomes quite easy for you. You don't need to declare it first itself, or let's say while you're working on your code, suddenly you realize a new variable has to be created. You don't need to go to the start and then declare it. So at any point, if you need a new variable to be created, you can create it right away. And we followed that same process here as well. So let's deep dive into each of these data types. We'll start off by understanding with vectors. Okay, now vectors basically is a sequence of data elements that are of a basic data type. Okay, now if you look at the example here, what am I doing is I'm storing numerical values into my vector. Again, the assignment with respect to the vector can vary with usage of the assignment operator, but vector in itself can be classified into 5 different atomic types, or they're better known as the 5 classes of vector. These are your character, complex, integer, numerical and logical value. Now in your logical value, you basically have your true and false. In numerical, it can be a numerical value, and in integer can have an integer value. Okay, you can also work around with complex number where there's a real and an imaginary part, and you can also work around with characters. Characters could be a single character, it could be a word, or even a sequence of words or a sentence as well. So your character variable would take a corresponding size, and R always takes care of the memory management, so you don't have to worry with respect to that. Now, let me just give you an example for each one of them. Let's go back to our R Studio. Now here, let's say if you want to clear the variables in your memory, all you need to do is click on this operator and automatically every object in your environment will be cleared. Okay, same for clearing your console, just press Ctrl L and your console is also clear. Now with respect to your logical variable, let's say A, okay, equal to, you have both true and false. So again, true has to be written in capital because this is a reserved keyword, and when you write true, you can see corresponding value has been set. Same can be with respect to B, which is going to store false value. Again, these are reserved keywords that have a certain definition already present in R, so you would get a correctly prompted response. So A and B are true and false. Now with respect to numerical values, let's say C is going to store 5. Okay, and I'm going to create another variable which is going to store an integer value. So D is equal to 5, and to denote that it's an integer, you need to add a corresponding L associated with it. This basically tells R that this is an integer value. Now here, when you look at your environment, C basically is a numerical value which is storing 48 bytes. But when you come down to D, you can see it is of an integer type that is using 48 bytes for its memory location. So Gayatri is asking me, how is integer different from numeric? That's a very good question, Gayatri. Okay, now if you talk about integers, they are actually used to store whole numbers. You cannot store a decimal pointed value or a fractional number inside an integer. But in your numeric, you can store decimal values in the float class as well as whole numbers. So basically your numeric could be the whole set, where your integer is basically a subset of your numeric. Does that answer your question, Gayatri? Again, if it's not clear, let's say E equal to 8.5 L. Okay, when I try to do this, it gives me a warning that integer literal 8.5 contains decimal, use numeric value. Okay, but when you see a new value has been created in my memory, and if I go there, you can see it is of type numeric and not integer. So does this answer your question, Gayatri? Okay. Now apart from this, let's say I have F, which is going to store certain character value. Let's say R is fun, and there you have it. So any doubts with respect to the data types that we have discussed till here? The 5 basic atomic data types. Again, here one thing you need to remember is while you're working with these atomic classes, you don't need to specify the data type for them, for the variable that is. Okay, automatically R checks the value and decides and assigns the data type for these variables. Okay, so it basically reduces your effort by half. All you need to do is decide a variable name and then fix the value for the corresponding variables. Okay, so any doubts? Now let's take a new empty workspace. Now as we had mentioned earlier, a vector basically is a collection of different data types. So let's take a vector VTR, and to that let me just store a sequence of numbers. Now again, we had done this earlier as well when we had seen these special operators, but again let's take the same case here. Let's say I'm going to store 1, I have 3, then I have 5, there's 11, 45, 23, 67, 55, and finally I have 41. So these are the numbers that I'm going to store inside my vector. Okay, so you can see here there's a missing comma between 67 and 55. So again, it makes a big difference when you're specifying different values, because it becomes hard for R to identify the different values. Okay, so now you can see a new vector has been created. I have 9 elements starting from 1, it goes all the way till 41. So this is a simple collection of vectors of numeric type, and 9 values are stored here. Similarly, you can have another vector 1 that is used to store different characters. I'll say hi, another hello, Again, characters need to be in quotes. Okay, these can be single quotes or double quotes, but always make sure you put it across correctly. And I'll put in a hey. So again, you can see these have been added correspondingly to the new vector. So even if you have a single element or if it's a collection of elements, it's always a vector. Are you clear with this? Okay, so some operations that you can perform using vectors are basically indexing, replacing, sorting. So let me just show you these operations as well. Now, okay, so this is a vector of different numerical values. So to sort it, let's say I'm going to create a new vector, say sort, and to that, okay, sort is basically a keyword. So I'm going to say sorted VTR. Okay, to this I'm going to sort my vector and then store it. So sort is an inbuilt function. You can call it and you can pass the data type here. So vector is what I'm going to pass, and then if you print sorted vector, then you can see the complete list has been sorted and is getting printed here. So any doubts with respect to the same? So this is something that you can perform for any data type. If you pass a character data type, then what happens is basically sorts based on alphabetical order. So here let's say VTR1, and if I print it again, so you can see it's rearranged everything in an alphabetical order. So as long as it's a vector, you can perform the sort operation. Apart from that, let me just take the vector VTR, and here if you want to access any specific elements, in that case just use a square bracket and you can specify which element you want. So let's say the second element, then press 2. So if you see the complete vector, the second element is 3. But let's say you want a range of values, then what you can do is 2 colon, I want the values from second position till sixth position. Then you just need to specify the start point and end point of that range, and all the values get printed with respect to that same, including the range values, that is number 2, 3, 4, 5 and 6. Okay, so who can tell me what will happen if I give -1 here? Okay, so all of you are telling me the last element will get printed. Okay, let's see what happens. Can anyone tell me what happened here? Yes, when you say minus of an index, it basically means excluding that index element, print everything else. Alright? Okay, great. Now again, let's say if you want to replace a specific element in your vector list. So let's say I want to replace the third element in my vector, that is 5, with let's say 15. It's a quite straightforward process. You just need to specify the index followed by the new value. And if you print the vector now, so now if you just print vector VTR, you can see the updated value where I had 5 originally, it's getting replaced by 15. So this is basically a replacement of a specific value. Are you guys clear with this? Okay, so one last trick question. What happens if I say replace it by 11? So I have 9 positions here. If I'm going to put 15th in my 11th position, what will happen? Okay, so some of you are telling it will not get added, some are telling it will get added to the 10th position. Let's see what happens. Do you think this command will execute successfully? Okay, I find a lot of yes and no, so let's try that first. Okay, it's got successfully executed. Now let me just see what my vector looks like after inserting to the 11th position. So you can see here it has been inserted into the 11th position, leaving a blank at the 10th position. That's the reason you're getting not applicable, NA here. Okay, so if you are adding a value to the index beyond the range with respect to some gap. Now I had 9, I'm leaving a gap, I'm putting 11, then all the values between that range becomes not applicable. But your value will get inserted into that position. So with this we've come to a conclusion with respect to vectors. Are you guys clear? Any doubts still here? Any doubts with respect to vectors? Okay, so with that we've actually come to an end with dealing with vectors. So let's move forward and talk about lists. Now lists are basically are objects that contain elements of different data types. Now again, so you can have strings, you can have integers, numerical values, boolean values, all that in a single element. So that's how it is slightly different with respect to vectors. It's the same thing, but it is just different with respect to what kind of data types that you can store. In vectors, we had seen that you can only store one kind of data types, but in list, you can store different data types. Let me just show you how to do that. Okay, so before that, let me just show you how vector converts your data if it's of different data types. So let's say vector 2, okay, is going to store hi, then it's going to store a numerical value of 15. I'll give an integer value of 21, and finally I'll add in true as well. So with this, I'm going to save it and it saves it. But what data type is it storing? Now to find that, let's say class is a function that helps you identify which class each variable belongs to. Okay, so vector2 is the variable which I had stored different kinds of data types in. And if I say enter, it tells me it belongs to character class. What does this mean? It basically means that all the values in vector2 have been converted as characters. So you can see every value, high, 15, 21 and true are in quotes. That means each one of these are characters. You can also verify that in your variable environment. So you can see this vector is basically of a character type and every value is being stored as a character. Okay, so same time let me create a new list that's going to store different kinds of values. So let's say list 1. And here you need to specify the type. So list of, okay, let's say hey is going there. I'll add false as well. I'll add 54 and 35 as integer. Now if you save this, there's no error here, but let's see what is present in list 1, whether they're being converted to character or not. So you can see here each of them are being stored as their original data type. List hey is being stored as character, false is set as false, 54 is 54 and 35 is set as 35. So here each of them retain their original data type, but whereas in vectors they get converted to character data types. So are you guys clear with this? Right. So you can perform the same set of operations that you had performed with vectors as well, but one thing that differs is, let's say I'm going to create a sorted list for my list. So here I'm going to say list 1, and who can tell me what is going to be the output of this? First tell me whether this command will get executed or not. Okay, let's go ahead and try it. It says it cannot. Because again, what happens is since you have different data types present here, it becomes hard for R to identify on what parameter it needs to sort out this data. Okay, let me just clear this workspace. So apart from the operations that we had seen earlier with vectors, these are some of the specific operators here as well. So let's say you want to merge two lists. Now these two lists can be of any type. So I have list 1, let me create list 2. That is going to have a combination of both characters and numerical values. I'll say hello, I'll add a Neil, put an R as well. I'll add 45 and 28. So this is a list that contains both character and numerical value. Now let's say I want to create a new list that is merged of my list 1 and list 2. So before that, let me just show you list 1. This is what my list 1 looks like, and this is how my list 2 looks like. So I want to merge these two data. So for that, what I'm going to do is I'm going to create a new list 3, okay, in which I'm going to merge this. Now to do that, you need to use this function merge, and here you can pass list 1 comma list 2. And you can see if you print list 3, then you can find a merged list with respect to both of them. Okay, so here you can see all the elements of that list have been merged to a single element. So you can see hey, false, 54, 35 from my first list, and then hello, Neil, R, 45 and 28 from my second list. So these two have been merged to a single list. So any doubts with respect to merging lists? Okay. Now apart from this, another way that you can combine these two is basically using them with respect when they're declared itself. So let's say 4 is equal to a combination of both my list 1 and list 2. Okay, now if I print list 4, you can see the elements present here, but let's say I just want certain elements from my list 4. Then what I can do is I can use an indexing parameter here. Now if I say 5 here, basically extracts hello. So 1, 2, 3, 4, 5 here. So this is basically extracting an element from a list. So I hope you guys are clear with lists. So let's move forward to the next data type, that is arrays. So now after vectors comes lists. Now with respect to lists, they're basically similar to your vectors, but the only key difference being with respect to vectors is that they can store elements that belong to different data types itself. So let me go ahead and show you on our studio itself. So I'll begin by creating two vectors itself called list1 okay, which is going to store numerical values. Let's say 1, 5, 7, 13 and 15. Okay, get comma, sorry about that. Okay, so I'll go ahead and create another list, say call it list 2. Okay, and this is going to have character elements present in it. So let's say I'll give in colors, say red, blue and green. Okay, so these are the elements of my list. Now what I'm going to do is I'm going to create something known as list 3, which is going to store both of these. Now these are basically vectors. Okay, so if I directly write list 3 equal to C of list 1 comma list 2, then what happens is it gets created, but when I print list 3, okay, all the elements of my list are considered to be characters, because again here it's just a vector that's being called list. To convert this to an actual list, what you can do is here you need to first change it and rename it as list 4, and you need to specify this is of a type list. Now when you do that, automatically R understands that list 4 is going to be of type list, and then if you create this, let's try printing list 4. So here you can see both the lists. One is completely retaining its numerical elements and 2 is completely having characters. They are not being converted completely as we had seen with vectors. Similarly, if you create list 5, which has a combination of all these elements, let's say list, and here I'm going to add 35, 49L, then I'll put in true and I'll add Neil. Okay, so I am taking 4 atomic data types and I'm creating list 5. When I print list 5, you can see here each one is actually retaining its original data type and they're not getting converted to character as we had seen with vector. So list can help your objects retain their original data types. So are you guys clear with this and the difference between lists and vectors? Okay. Now apart from the operations that you had seen earlier, there are certain operations that we have already seen. Now again, you can merge to list as well as you can perform slicing. Okay. Apart from that, you can standardly perform your indexing as well as slicing. So that's something that you can definitely try out. Now coming to the next data type is arrays. Now basically the purpose of arrays in R is to store your data in more than 2 dimensions. Okay. To store it in 2 dimensions, you have matrices, but we'll talk about that in the next part. But basically what you need to understand is that array helps you store data in more than 2 dimensions, and it usually takes vectors as input parameters. Okay, now what I'll do is let me just clear all this. So talking about arrays, basically I'm going to create 2 vectors here. Vector 1, which basically is going to have 5 numerical values. So here I'm going to have values 2, then I have 6, I'll add 14. So basically certain random numbers itself, then 22. So 5 values present in my first vector. Okay, I'm going to create vector 2, in which let's say I have 5, I have 15, 25, 45, 65, 85, 105 and 125. So basically I have 2 vectors present here. One has 5 elements, the other has 8 elements. Okay, now to create an array, what I can do is I can say ARR, let me just call it my array ARR. Then following that, I need to specify the array type. So basically this is my array type, and then I need to provide it an input. So let's say C of vector 1. So now what I'll do is, now I've just created a single dimensional array. Let me just show you how the array looks like. So if I just print ARR, so this is how my single dimensional array looks like. Now the purpose of array is to create it as multi-dimensional. So let me just show you how it's done. Now what I'm going to do is I'm going to make a multi-dimensional array here. So I'll just call it array 2, and instead of just passing vector 1, I'll pass vector 2 as well. Now apart from this, I'm going to specify the dimension how it has to be. So I'm going to slightly change the dimension here. So to do that, just use dim. Again, dim basically is supposed to set the length, and here I'll pass a vector which tells how the dimension should be. I want to have 5 elements in my first row, 5 elements in my second, and 3 elements in my third. So this is basically how I'm going to define it. Once I've done this, and if I print ARR2, so you can see how my matrix looks like. So if you see the values here, it may look slightly jumbled. So let me just help you understand this better. Now I've taken first 5 values from vector 1 and then I've stored it in my first column. So if you see that, they've been stored correctly. Then what happens is in my second column, I'm taking continuous values. So 5, 15, 25, 45 and 65 have been stored. So that is my limit. The values following that will start from the next column. So again 85, 105 and 125. I'm at end here. But again, since I have to store the values continuously, again you're starting from 2, 6, 14, 18, 22 and again you're starting from that next list. Since there are 3 copies being created, the order continues. Where it stops at 100 and 105, you're starting with 125 in the next one. So I hope you guys are clear with respect to how our data is being stored in an array in R. So any doubts with respect to arrays or lists? Okay, it's great to see that you guys are following. Now apart from arrays comes your matrices. Now matrices are quite similar to your arrays itself, but only difference with respect to your matrix to arrays is that it's not a multi-dimensional, it is just two-dimensional rectangle. So there you had seen we had created a combination of a matrix of 5 cross 5 and we had created 3 of them in a single array. Now if you go back to that, let me just show you another feature there. Now here let's say I'm going to add another value, let's say 2, and I'll call it array 3, and if I print array 3, then you can see it is storing it into a multi-dimensional form. So I have a matrix here which is again in turn getting stored inside another matrix. So you can see these are the first 3 rows for the first column, these are the next 3 rows for the second column. Okay, so it's a combination of multi-dimensional elements here. But when you talk about a matrix, it basically is used to store elements into a two-dimensional format. It's quite simple and is more of the basic fundamental here. Okay, so let me just clear all this and clear the variables as well. Now the syntax for creating a matrix is quite straightforward. You specify the keyword matrix followed by the data that you need to pass. It could be multiple vectors together, and then you specify the number of rows, number of columns. By row basically is a logic by which your row elements have to be arranged, but for now don't worry about that, and dimension names. So let's go back to our RStudio and try it out. I'm going to create 2 vectors. Again, vector, okay, let me just take the previous states. So I'm going to take the same vector and I'm going to modify this vector. Okay, so basically I'm creating 2 vectors, vector 1 and vector 2, having different values. Both have 5 elements presented. Now let me create a matrix mtr of the type matrix again. So when you type matrix, okay, now again there is a highlighted here. It helps you understand what should be the syntax for this function. So as for the first part, that is the data, I'm going to say vector 1 comma my vector 2, and then I need to specify the dimensions. Now I can either make it a 5 cross 2 or a 2 cross 5 element. Now again, the filling of the elements starts column wise, so always the data will be filled down. So what I'm going to do is I'm going to make it a 5 cross 5. So number of rows is 5, number of columns is 5. Okay, and when I hit enter, a new matrix is created. But to see the data elements in the matrix, just type mtr and you can see the elements. So here if you see, first vector is getting inserted into the first column completely, the second column is getting completely filled with the second vector, third column with the first vector, fourth column with the second vector, and fifth column with the third vector. So always the data filling happens in a column wise sequence. So any doubts with respect to vectors? Okay, so Reshma is asking me what happens if I give different dimension. Okay, definitely, let me just show you that as well, Reshma. I'll just make it mtr1. Okay, and here what I'll do is I'll change it to, let's say, 8 cross 5, or let me just make it 8 cross 6. Okay, the problem with this when I try with this is that it goes beyond the range. Now I'll just change it to 3 cross 4. Again, that case it does not get created. So not all values come into the picture because it's not a sub multiple. But let's say I'm going to make it 10 comma 15, then it gets created because it's a complete multiple. Okay, so I'll just print my matrix 1. So you can see here a 10 cross 15 matrix being created. Okay, so it needs to be a multiple with respect to the original number of values present in that matrix. Is that clear? Reshma, what you need to do is if you are creating a different dimension from the vectors that you have, then make sure your number of rows and columns are a multiple or a sub multiple of the number of elements present in that vector. Is that clear, Reshma? Okay. So moving forward, let's talk about the second last data type of today, that is factors. Now, Factors basically are something that are used to categorize the data into levels as such. Okay, now here you can use it to categorize both strings and characters, and apart from that, this is something that you'll extensively be using when you're working with different statistical models. Now it's quite straightforward. Let me go back here. I'll just clear everything here and from here. Okay, so let's begin by first creating a new vector. So I'll just say vt1, and here let's put new values. Let's say 3, 5, 7, 11, 5, 15, 11 again, 23. Okay. Once you hit it, a new vector is getting created. Now what I'm going to do is, now I'm going to create a factor out of this vector. For that, it's quite straightforward. I'm going to create a new factor variable, fact vtr. Okay. On this, I'm going to convert factor, and I'm going to pass the parameter of vector. Once I have created this, a new fact vector is created. Okay, so to see what is the value inside fact vector, you can just print the variable. So you can see here the different values that are present here, but their unique values are denoted by the levels. So this is something that will definitely come into use while you're working with statistical modeling. So there may be situations where you'll be seeing different values, but to understand the unique values, you can always convert those values into factors and check their corresponding levels. So it's a quite straightforward process. So let's say you're working with a data that has different probabilities. To understand the unique probabilities, you can always take that data and convert it to factors, wherein you can identify the levels to identify what are the various possible probabilities that are present in that data. Okay, so are you guys clear with factors? Alright, that's great to hear. So moving forward, let's talk about data frames. So data frames is something quite interesting that you'll be working with R, and is one of the most widely used data types after vectors in R. Okay, now with respect to what exactly is a data frame, it could be a table or it could even be a two-dimensional array-like structure. Okay, now in a data frame, each column actually contains a value from one variable, and each row actually contains from one set of values from each of the columns. Now rather than explaining this, let me just go ahead and show you how it works out. Okay, what I'm going to create is I'll create a new vector, let's say ID, and this is going to store a range value from, let's say, 100 to 150, or let's say I'll just take a smaller number, let's say 105. So 5 numbers are going to be inserted into ID. Apart from that, I'll say name. Okay, name is going to have, let it have my name. Okay, so I'll add in Eric's name as well. Then we have Dave as well. Okay, Dave, I hope you don't mind, you guys. Okay, not a problem. Then let me add Roshni as well, and let me bring in Pankaj. Okay, so these are the 5 names. Now what I'm going to do is I'm going to create a data frame that combines these two vectors. Now how do I do that? Let's say I'm going to call it class std. Okay, that means it's just a single name. Okay, now this is going to take a data frame, data.frame, and here I need to pass the values. So id comma name. Once I do this, it gets created, and let's see, repeat. Okay, so this is problem because there's a difference with respect to the number of elements between both. Now here, if you see, ID has 6 elements, whereas name has only 5 elements. So in that case, what I'll do is I'll just go back to my name. I'll just clear all this. So I'll say name of 6 is equal to Reshma. Okay. So now I have 6 elements. Now if I try the same, it gets created. And if I print this, let's see how the output looks like. So here you can see they are getting linked together. Each ID is getting a corresponding value from the name. Okay, now similarly, let's say you have another field, let's say marks. Okay, please don't mind this, and I'll say 80, 85, 87, 95, 92, and 89. Okay, so 6 values. Now I'm going to create another new data frame, std1, and here similarly I'll pass the third vector, that is marks. Now if I print the class std1 data frame, then you can see correspondingly each row has a value from each of the vectors. That is, one element is getting picked from each of the vectors and correspondingly they are being linked and put in a row. So any doubts with respect to how a data frame looks like and how a data frame works? So a data frame is something that you can definitely use while you're working with different tables. So let's say you're extracting a table from a CSV file or an Excel file. In those situations, your data frame will be something that will definitely come into handy. Okay, so for now, don't worry too much about it. We'll be extensively talking about importing and working with different data sets in the next session. But I hope you guys are clear with respect to the different data types. Okay, so I've got a confirmation from Eric, Shubham, Reshma, Pankaj, Gayatri. That's great to see. Adam, okay, that's nice to see that all of you are following. So with this, we come to a conclusion of data types. So I'm quite sure some of you are familiar with programming languages. And in programming language, there's a very important concept known as flow control statements. Now, what these control statements actually do is they divert and control the flow of every program, as in the sequence of execution of these programs. So in today's session, we'll mainly be discussing across 8 of these different flow control statements. You have if else, switch, repeat, for, while, break and continue. Now, if else and switch are your selector statements, whereas your repeat, for, while are your loop statements. Break and continue are jump statements because they help you jump from the sequence of the operations. Okay, so we'll start off by talking about the selector statements. Now, talking about selector statements, they have just a simple aim, that is they choose certain set of operations after evaluating a condition so that you don't have to bother to the exact detail. Now, there are mainly 3 selector statements. You have if else and switch. Okay, if actually evaluates just a single condition and decides and what has to be done in case the condition is true. If it's false, it just ignores it. Now, if else is a group of statements that can help you check multiple conditions. It's similar to the if, but it helps you achieve a bigger branch. Switch basically helps you check the different possibilities which are already known to you. That is, if a certain variable can take a specific value, then you can go with switch. So the first topic that we'll be discussing is the if statement. Now, if statement is quite straightforward. It just has a single keyword if followed by the condition and then a certain set of statement that needs to get executed in case it is true. Now, if you look at the image to the right, this is basically the flow of if control. So you start off your code, you check the if condition. If it is true, the conditional code or the statement written inside the if will get executed. If it is false, the statement gets ignored and you will move forward. Now, before we go ahead and look at an example of if, I'd like to discuss about if else as well, because these two statements are completely related. Now, you can use if and if else or an else if ladder that will help you achieve the following order. So what you do is you first check the code. If it is true, that means the first if code gets executed. If it is false, then it goes on to check the else if condition, and if it is found true, the else if gets executed. Finally, even if the else if code is found to be false, then you go ahead finally to the else code and it gets executed. That is, in case if none of these conditions are true, then you execute the else statement. But you can have a multiple chain with respect to if else. You can have any number of if else conditions that you want. But it's suggested that you do not write too many because it becomes confusion for the user as well. Now, to see the practical example of the if else statement, let's go back to our RStudio. So let's begin by creating a new script file in which we'll write our code and directly execute it rather than writing it on a console. So first let me begin by creating a new variable called x, and this is going to have a value of 5. Now comes my if statement. If x greater than 3, then print x is greater than 3. Now to run this, just click on the source option here and directly it will convert it and execute it on the code. So you can see x is greater than 3. But let's say I'm changing this value to 5. And then I'm rerunning this code, but there's no output here. Can you see that here? There's no output here because the statement written inside the if does not get executed. Now in such cases, what you can do is you can write an else condition where the if condition ends, else print x is not greater than 5. Okay, now you can run it and you can see printing x is not greater than 5. But let's say you want to add another condition here. Then what you can do is you can write an else if x is equal to 5, then print x is equal to 5. Okay, let's run this and see. Sorry, double equals to. Always remember that for comparison it's all double equal to. You can see it's printing x is equal to 5. So any doubts still here? How the if-else ladder works? Okay, so I've got a confirmation from everyone. Gayatri is asking me, is there a limitation on if-else? No, Gayatri, definitely. You can use a continuous nest of if-else, if and else statement any number of times that you want. So it's all up to you, but again, the more you put conditions, the slower your code becomes, because it needs to check every condition with respect to that same. Okay, so make better decisions when you're doing that. Alright, now the third kind of flow control statement is the switch case statement. So switch case is basically used to compare a certain expression to a known value. That is, you're already aware what value that variable can take, and based on that, what has to be done. So let me go back to my RStudio. I'll clear all this. For in case of switch, let's take a new vector here. Let's say VTR is my new vector, and to this I'm going to add certain values. So CF, let's say 150, 200, 250, 300, 350, and finally 400. Now what I need is I'm going to write a new variable that says option. Now option basically is going to be the expression to be evaluated. Now in this case I'm just assuming it to be equivalent to mean, and then I need to identify mean of this operation. But in general cases it can take any values, and that's exactly why we take switch case. So here if I write switch, I need to specify first the expression. So my expression is with respect to option. After that put a comma. Then it can be mean, which is equal to, now to compute mean you already have an inbuilt function, so which you just need to pass the parameter. So in this case it's my vector. Now to move to the next case, just put a comma. Let's say mode. Again, mode has an inbuilt function. And finally, let's say median. Now all these results have to be printed, so add a print before it. And then you can directly close the switch case statement. So with this we've completed the switch case, and let me just run this code. And you can see here 275 is the mean of this vector, which has different values ranging from 150 to 400. So from this range value, the mean is found out to be 275. And if I say median, then the median is also calculated. So I hope you guys are clear with respect to switch case statement and how they work. Any doubts? Okay, how do you write default statement? Okay, default statement is quite interesting here. Just put a comma and then you can write I'll just change it to ME, and then if you try to run this, the default case is considered. So as long as you don't specify the case and the last option is considered to be a default state. Is this clear, Varun? Okay, that's good. So with this we actually come to a conclusion of our flow control statements. The next kind of statements that we're going to be talking are loops. Now what do loops do? Loops basically help you repeat a certain set of actions so that you don't have to perform them repeatedly. Now the main objective of a loop is quite simple. It basically helps you repeat a certain set of actions n number of times so that you don't have to manually write it. Now imagine I need to perform an operation 10 times. So if I start writing the code for it 10 times, then what happens is the code length increases and it becomes a problem also for the user to understand. But at the same time, by using a loop, if I write the statement I want to execute 10 times inside a loop, then it saves me the code length as well as it makes easier for code readability. It also optimizes with respect to code efficiency. Now repeat statement and while statement helps you execute a certain set of codes until the condition is true. But for is a kind of loop statement that you use when you know how many times you need to repeat that statement. Now let's say you want to repeat a set of statements 10 times, then you'll go with the for loop. But let's say you're not quite sure on how many times you want to repeat it, then you go with the repeat or while loop. So let's move forward and start talking with respect to the repeat statement. Now this is the basic syntax of the repeat loop. So first you start and then you execute your code. Once you've executed it, you check if the condition is true, and if it's true, you go back and execute the block until the condition is meant to be false. Once it's found out to be false, then you break from the loop and you exit. So this is the general syntax. You have your repeat keyword, then you have the commands that need to be executed. Once the command has been executed, you need to write a condition based on which the loop statement will exit or not. So let me show you how it's done. So let me just clear all this. So let's say repeat. Now here let's say before this I'll just declare a variable, say x is equal to 1, and I'll say x is equal to x square. Now I'm going to write if, I'll change the value of x to 2, if x is greater than 100, then break. Okay, before this I'll just print x so that we can follow it, and then it's time we execute this code. So you just run this and you can see the value of x first reaches 4, then it becomes 16, and then once it becomes 256 we realize it's greater than 100, so we break from that loop. Again, if I add another 0 and rerun this, then you can see from 256 it's again getting squared, and the number is becoming 65536, which is greater than 1000, and you're breaking from that loop. So basically, in situations where you're not quite aware of how the value is changing, but you know at one point where it has to stop, then you use a repeat loop. Similarly, a while loop is also quite the same. If you go back to your presentation, while loop actually starts by checking the condition and then it executes the code block. Okay, and once you've completed execution of the code block, then it goes back and checks the condition. As long as your condition is found to be true, it will keep executing the code block, but the moment the value is found to be false, then you exit from that loop. So let's go back here and I'll modify the same code for while loop. So here what I'll do is I'll change it to while. I'll bring in this condition and I'll remove the condition from here. So how your repeat and while loop changes is, earlier with respect to your repeat, you had actually changed this condition to be greater than 1000, but in case of while loop you're basically going to change it to less than 1000. That is, if the value of x is less than 1000, then only enter that loop. Okay, now if you rerun this code, then you can see the output present here, which was same as our repeat loop. But the major difference here is change with respect to the condition. Now your while loop basically defined when you're going to enter the loop, whereas your repeat loop defined when you're going to exit from that loop. So these two statements are better known as entry control loop and exit control loop. Your repeat loop is something that defines when you leave from that loop after you've completed execution of the statement. But as your while basically controls when you're going to enter into that loop to execute the statements. Okay, that's how your repeat and while loop are different. So I hope you guys are clear with respect to both these loops. Okay, Reshma says yes, so does Gayatri, Adam. That's great to see. Okay, so the last kind of loop that we'll be discussing is a for statement. Now, your for loop is quite straightforward. Okay, when you know how many times a loop has to be executed, then you can directly go ahead and execute. So let's say I'm going to define a new vector, VTR. Now in my vector, what I'm going to do is I'm going to add 5 elements, 7, 19, 25, 65, 45. Okay, now I want to print them one by one instead of individually printing all of them at one go. So in that case, what I'll do is I'll use a for I in my vector VTR. Okay, so for every value in my vector VTR, I'm going to print that value. So basically you just need to write print of I. Okay, so if you run this, you can see all the values are individually being printed here. Okay, but if you just directly print VTR, you can see the difference between both. So where one is printing each value in new line, when you print the whole vector, all the numerical values are present in the same line and are considered to be one entity as part of the whole vectors. But here you can access each of the values one by one. So I hope you guys are clear with respect to how to work with the for loop. Okay, so your for loop is something that you'll definitely be using while you're working with matrices as well as arrays and some amount to data frames as well. Okay, so keep this in mind because this is an important concept. Now comes your break. Again, so you've seen how break statement works while we had seen our repeat loop, but none of you actually put across the question what a break statement was. So a break statement basically helps you come out from the loop whenever it is being called. Now, if you look at the image here, first what you do is you check the loop condition. If the loop condition is found to be false, then you exit from that loop. After that, you come in and you check if the break condition is true. That is, inside a condition when you have written break, that condition is it true or not. If it is true, then it will encounter a break and it will exit from that loop. But if it is not true, then what happens is the code written after break gets executed and then you go back and repeat the whole loop once again. So after your break comes the next statement. Your next statement is quite similar to the continue statement that you would have seen in other programming languages. Now, what actually happens is your next is slightly opposite to your break statement. Here, instead of leaving from that loop, what happens is if you encounter the next statement, every code that is written after that does not get executed and you go to the next iteration. Okay, so if you look at the flow diagram here, you check first the loop condition and then let's say you have certain codes written before the next condition. Then you check if the next condition is found to be true or false. If it is false, then you'll execute the remaining code written in that block and then you'll go to the next iteration. But let's say if the condition is found to be true, then you do not execute the code written below it and then you iterate to the next loop. Okay, now it may seem slightly confusing, so let me go back to my RStudio and show you how it works. So here what I'll be doing is I'll say for I in, let's say I'm going to give a specific range, so 1 to 15. Now in this range I don't want to print even numbers, so for that if I modulo 2, that is when I divide I by 2 the remainder is equal to 0, then go to next. If not, print I. Okay, so let's try executing this code. So just run this and you can see only odd numbers are being printed and even numbers are not getting printed. So basically every time this statement is found to be true, the next keyword is being encountered and then the print command is not executed. So it goes to the next iteration without checking the code written after this. So I hope you guys are clear with respect to these flow control statements. Okay, that's great to see. I've got a confirmation from Reshma, Gayatri, Roshni, Adam, Shubham, Pankaj. That's great. Till here we've seen the analytical aspect of R. So now let's move forward and look at the visualization aspect of R. So with respect to visualization aspect in R, you can create these 6 different kinds of plots using a data that you have. Now, I'll be showing you an example of how to create each one of these plots one by one. So we'll begin by first talking about pie charts. Now again, when you talk about pie charts are best used to compare different parts of a whole. So again, let's say you have different branches. To identify which branch is getting you most sale, it would make more sense to plot a pie chart with respect to all the branches or details. Okay, so to create a pie chart, it's quite easy. Let's go back to an RStudio and I'll show you how to do that. So I'll just clear all this. Now, let me clear the memory here as well. I have a vector VTR in which I'm going to have percentage of my 5 departments. Okay, so see, let's say one department is contributing to 14% of my sales, the other is contributing with respect to 28%. Then there's a department that contributes 11%, and then there's one which contributes to 30% of mine. And finally I have another one which contributes 17%. Okay, so these are the different percentage with respect to each department. But to understand better which department is contributing to each value, I'm going to create a new vector as well that's called names. So here I'll just give some of the departments. I'll say R&D, then let's say I have marketing, I have corporate, then there's sales, and finally I have support. Okay. Now with these two values, I'll just show you how to plot a very simple pie chart. Now if I just say pie of VTR comma name, So you just need to run this code and you can see the plot has been provided to your left. So here you can see the contribution of the different departments. You have marketing, you have corporate, sales, support and R&D, and a pie chart has been created from the corresponding values that you have taken from vector. So this color seems a bit dull for me. So I'm going to say COL equal to rainbow. So rainbow basically gives me different values. Now, how many different values do I need? I need length of vector. That means with respect to the total number of values present in vector, please give me different colors. Now if I run the same code again, so you can see the change with respect to the colors. So this looks a little more better. So this is not the end of capabilities with respect to pie chart. There's a lot more that you can play around, but this is just to give you a simple idea that you can plot a pie chart like this. It's basically with respect to 3 simple steps that you're writing in R. Okay, now apart from this, the next type of graph that we'll be looking at is bar chart. Now your bar chart are basically used to compare things between two different groups or track the progress of certain things with respect to different times as well. So let me show you how simple it is to plot a bar chart as well. Now for your bar plot, I'll just modify the same content. I'll just remove this line. I'll say bar plot and I'll just pass VTR. So this is all the value that I need for plotting a simple bar chart. And if you run this, you can see a bar chart with respect to the different values present here. So you can always zoom and see a complete bar chart. Apart from that, let's say if you want to even export this image, then you have the option to save that through R. Okay. So this is how you plot a simple bar chart. Now, apart from bar chart, you can also plot a box plot. Again, when you talk about box plot, this is mainly used to summarize the data from multiple sources and display the result basically in a single graph. So again, when you summarize the data from different graphs, it becomes a problem for you to use any other representation to understand better the difference or the change as well. So your box plot definitely helps you achieve that. So let's modify the same code to create a box plot. Okay, so for bar plot, what we'll do is we'll be using a standard input data set that is present in our library, that is empty cars. So to see the data set, let's say empty cars is there. So if you just print this, you can see the complete list of empty cars. Now here what I'm going to just take is I'm just going to take the name. I'm just going to say the maximum power with respect to the cylinder, and then I'm going to create a bar plot with respect to that same. Now this is a simple command that I have written here that will help you achieve the same. Okay, so these two columns have to be selected. The data is from empty cars. In your X label, it should be number of cylinders. Your Y label should be miles per gallon, and your main plot should be with respect to mileage of data. If you run this, you can see the graph present here. Let me just export it so you can see the data. Now let's say you want to give color here, then all you have to do is put a comma, call is equal to the colors that you want to pick. Any 3 colors. Okay, I have red. Okay, yellow, something else. Okay, blue. Okay, sure. Okay, so these are the 3 colors that I want as part of my bar plot. Just close this. And now let's try rerunning this. So you can see they've been colored as well. So if you just zoom on this, you can see the 3 different colors that they have taken up. So again, you don't need to worry how exactly it is working, because our next session is completely devoted to visualization in R. Okay, but I just wanted you to have an idea on what and all types of graphs you can plot in R and how simple and easy it is. Now the next type is histogram. Now histogram is one of the most easiest graphs that you can work with. Histograms are basically used to plot frequencies of continuous data. So again, this is one of the most common kind of graphs that you will be preparing as part of R, apart from scatter plots. So definitely this is something that is quite easy as well. So let me just show you how to do that. So in our R studio, let me just remove all this. Let's say vector 1. Okay, throw at me some random values. Okay, so 9, 11, 25, 70, 3, 4, 5, 9. Okay, this is my source data, and based on this I'm going to create a histogram. So to create a histogram, it's just hist, and then you just need to pass vector 1. Now if you run this code, then you can see the histogram here. Now it feels a bit dull, so what I'm going to do is I'll just close this. Let's say call is equal to blue. Again, it needs to be in quotes, and I'll also give a border. Let's say border is red. Okay, if you just rerun this, so your histogram's got a little more color with respect to that same. Now, although there are certain inconsistencies, but this is because we've just taken a random data set. Again, so all it requires is just one simple command for you to create a histogram, and it's quite easy with respect to that same. Now, coming back to our presentation, the next and second last graph are line graphs. Now, line graphs are something that's quite interesting. You can always plot different kinds of line graphs. It could be a single line, it could be multi-line, it could be a single line, it could be two lines, it could be multi-lines. So any number of lines as long as you have the correct information. Now let's go back here. So let's go ahead and modify the same part itself. So we'll just consider the same vector1 and I'll just say plot. I'll just pass vector1, comma, the type. Again, type takes a value p to either draw only points, I to draw only lines, and o to draw both points and lines. So since we want both, I'm going to pass the value of type to be o. Okay, now if you just run this, you can see a line graph being plotted for the different values that we have passed. So it's again quite simple, and the final kind of graph that we'll be discussing is scatter plots. Scatter plots actually tell us how one variable is basically affected by another variable. So this could be with respect to two different criteria itself. The change in value of one, how badly does it affect the change in value for the other? So this is something that can definitely be understood using a scatter plot. So let's go back to our RStudio. So here all you need to do is, let's say you already have another vector. So I have vector 2 present here. So I'll say vector 1, vector 2, and instead of type O, I'll just let it be blank. That is, plot a scatter plot across vector 1 and vector 2. So these are the values present in vector 2. And if I just run this, you can see the scatter plot that is spread across these two values for vector 1 and vector 2. How the variation makes a difference with respect to both. So again, it's quite straightforward to plot any graphs in R once you've analyzed it. It's just either a single line of command or maybe two lines of command at the max. So the main agenda of showing you these different kinds of graphs is to let you understand how easy it is to plot them. So I hope at least you've got an understanding with respect to that same. Now don't worry if you've not completely understood on how these graphs are created, because as I had mentioned, our next session extensively deals on that. We started this session by first understanding why do we need analytics and what exactly is data analytics. From there we moved on to understand why R and the various data operators in R and the data types in R. Finally, we talked about the flow control statements and we saw data visualization in R. So any questions with respect to today's session, any concept that you're not clear with or any point that you have had doubt in? Okay, since none of you have any doubts, it was a great session. Thank you and hope you have a great weekend.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!